Let's look at example 2. A teacher asked her 8 introductory statistics students to record the total amount of time they spent studying for a particular test. The amount of study time x in hours and the resulting test score y are given in the table. So the first thing we are asked to do is to make a scatter plot of the data and then find the linear regression for the data and correlation. So one thing you should be doing when you make your scatter plots is, if you're being asked to draw it, make sure you put your scale on. So I'll take a second to do that, and you can do yours as well. So go ahead and use your calculator to give you a rough idea, but do indeed plot it out as you would without the graph. All right, so here you can see my graph. You could have chosen data, which we'll copy down in a minute, and we can have a look at our graph from this, and I've got the best line of fit there. So we'll just jot down our information from this. All right, so you can see I've just taken a screenshot of our data. So from our scatter plot, we can see that the data is roughly linear. So our equation becomes the score, and remember with cap, this is our predicted value, is 12.94, that's what B is, times the hours studied, plus 60.71, so that's A. Our R squared from our display is 0.656. So explain what the slope of the true regression line beta says about the relationship between the time spent studying and the test scores. So what we can explain here is that there is a 12.94 mark increase in test score for each hour studied. Okay, for D, what is the estimate of beta from the data? What is your estimate of the intercept alpha of the true regression line? So our estimate beta is simply the same as our B from our calculation, which is 12.94. The estimate of alpha is A from our data, which is 60.71. Use your calculator to calculate the residuals. Find the sum of the residuals and the sum of the squares of the residuals. Use these results to estimate the standard deviation sigma in the regression model. So we'll jump back to our calculator. Okay, so I'm going to put our residuals into L3. So I can do that by going at the top of L3, list, and 7 here is residual in my case, and enter, and there they all are. So out of here we can then look at the sum, and from that we can see that the sum of the residuals is essentially 0. The sum of the squares is 560.35. So we can take a screenshot of that as well. The sum of the residuals is equal to 0, essentially. The sum of the residuals squared equals 560.35. So remember, this was from, we put the residuals into L3, and then we did one of our stats. And so when we now want to find the standard deviation, our estimate is going to be S, which is the standard deviation of our y residuals. So how it works is it's the sum of the residuals, so y minus the expected value squared, divided by n minus 2. And so when we work this out, we get 560.35. We had 8 students, so n minus 2 is 6, and we get 9.66. Now we'll see later on that when we do t-test, we actually get this number on our t-test results. So the standard error of the slope, SEB, is defined as, and this is on your equation sheets, the square root of S, that we just found up above at 9.66, divided by the sum of the difference between x minus the mean of x squared. So we will go and calculate that. In this case, we can calculate the sum of x minus x bar squared, and we can calculate that as follows. All right, 5 is sum, and we would like to take the sum of, we'll need another bracket here, and we will use L1, which is our x values, minus the mean. So once again, I went into list, math, and number 3 is mean of L1. And another bracket, square that, and close our brackets. And we get 6.375. So from our calculator, we got this as 6.375. And so SEB is then equal to the square root of 9.66 divided by 6.375, which is then equal to approximately 3.827. All right, next step, we're going to move into doing our t-test. So state the hypothesis that you would use to test if the number of hours spent studying helps to predict the grades earned on the statistics test. So our null hypothesis is that there is no relationship between the number of hours studied and the test score. So what we have there is that beta equals 0, the alternative hypothesis. Now, we don't expect that the studying would decrease test scores, and if it did, then that would be a bad thing. So our alternative is going to be one-sided in this case. The number of hours studied increases test scores. So beta is greater than 0. So we're now going to calculate the test statistic, degree of freedom, and p-value of t against the alternative hypothesis, and state our conclusion at the 10% significance level. So we will use our calculator. So to do this, we will go stat tests, and we are going, in mine it's letter E. You're looking for lin, reg, t-test, a linear So the t-test here, and we select that. We will choose L1, L2, because those are where our x and y values are. And in this case, we need to come down. Beta is greater than 0. I'm going to results of our test. Y equals a plus bx. Beta is greater than 0. We get our t value, our p value, degrees of freedom. A, remember, is the y-intercept. B is the slope. S is our 9.66, that's our standard deviation of the, that's our residuals, standard deviation. R squared R, which you can see that we get those 3 pieces of information off of the t-test, so that could have saved us a bit of time in our previous calculations. So next time, unless you're being asked to show how you calculate that 9.66, you can just take it right off of here. So off the calculator, we get that t equals 3.38 degrees of freedom equals 6, and our p-value equals 0.007. So, since our p-value is less than alpha, 0.007 is less than 0.10, we reject the null hypothesis, and conclude there is strong evidence that there is a positive linear relationship between test score and hours spent studying. Now we need to calculate a 95% confidence interval for the slope of the true regression line. So our equation here is b plus or minus critical value of the standard error of b. And once again, we know the degrees of freedom equals 6, and so our critical value then is 2.4, I believe that's 2.447. And so that we can get from our table. So from here we get 12.94 plus or minus 2.447 times our SEB that we had before, which was 3.827 from above. And that gives us a range of 3.57 56 to 22.307. Now there is, if you've got TI 84 plus or other such calculators, you do have lin reg t int, and that will give you the information that we require. That'll give you this interval. Unfortunately, the TI 83 pluses don't have this. So that's our interval. That concludes today's lesson.